Okay, so we have a question from Brown, chapter 20 on electrochemistry. The question is as follows. A voltaic cell similar to that shown in figure 20.5 is constructed. One electrode compartment consists of a silver strip placed in a solution of silver nitrate, and the other has an iron strip placed in a solution of ferrous chloride. The overall cell reaction is this. So that's the net reaction. And they're asking us to show what the voltaic cell looks like. So we drew the voltaic cell, and then asked a number of questions. The first question is, what is being oxidized, what is being reduced? So what I did is, to find out what's being oxidized and what's being reduced, I wrote the half reactions. So in a sense, before I could answer this question A, I wrote the half reactions. And we show iron as an oxidation. Iron is undergoing oxidation because it's giving up electrons. Loss of electrons is oxidations. Remember, Leo says GER. So loss of electrons is oxidation. We get a positive oxidation potential. So the way the reaction is written, because it's got a positive oxidation potential, it indicates that the reaction tends to be favorable in that way. The other reaction is the reduction of silver. Gain of electrons is reduction, again using the mnemonic to remind ourselves. So an electron is being added to the silver cation to give metallic silver. This also has a positive reduction potential. So the total voltage obtained by writing the reactions in this way is 1.239 volts, and that's portrayed here in the form of a little rectangle with the number 1.239 in it. This represents a voltmeter attached to the two electrodes dipping into the solution. This solution is composed of silver nitrate. This solution is composed of ferrous chloride. So these metallic electrodes are immersed in that solution. This is an iron electrode. This is a silver electrode. So we see that to answer question A, the iron is being oxidized. So we see the iron is losing electrons. And silver is being reduced. So silver is gaining electrons. How did we decide that? Well, when we wrote them, one as an oxidation, one as a reduction, they both have positive potentials. If it was written in this way, that one of them is negative, the reaction might still go as long as the other reaction has a higher voltage to drive it that way. But then the overall voltage would be lower. In question C, it asks which electrode is the anode and which is the cathode. The one thing I remember to remind me how to write these galvanic cells properly is that the cathode attracts cations. So the positively charged ions are attracted to the cathode. Why? Because the cathode has a surplus of electrons available. So the negative charges that are building up in the cathode will draw the positively charged cations. So the silver cations are drawn to the cathode, where they pick up electrons and the silver becomes reduced. So the cathode attracts cations and the cations undergo reduction. On the other side of the cell, you have the anode, where oxidation takes place. Now I suggest you memorize one or two key facts. Like myself, I've memorized the cathode attracts cations. And then I reconstruct everything else from that point, using the half reactions as a guide. We have a salt bridge here to make sure that the charge balance is maintained, because as the cations, as the iron atoms come off the anode and go into solution, because the electrons are moving out of the anode, forming these ferrous ions. As more ferrous ions go into the bulk solution, you get a surplus of positive charge. So that surplus of positive charge has to be balanced, and it's rebalanced by the movement of chloride anions into the solution. On the other side, on the cathode side, silver cations are being deposited onto the silver metal strip, and that reduces the number of positive charges in the solution. So how is that rebalanced? By the movement of nitrate anions into the salt bridge. So the salt bridge serves the purpose of making sure that the reaction isn't stopped by a surplus of charges building up in each one of the cells. To answer question C then, the anode attracts anions because of a surplus of positive charge, which means electrons are leaving it. Iron metal is being oxidized to form ferrous, while on the other side, silver cations are attracted to the cathode which deposits silver metal. So this silver electrode is getting heavier as the reaction proceeds, while this one here is being eroded. It's becoming lighter as the reaction proceeds. Part D is answered by saying the cathode is negative and the anode is positive. Question E. Do electrons flow from the silver electrode to the iron electrode, or from the iron to the silver? The electrons are flowing this way. They're going from anode to cathode, from the iron electrode to the silver electrode. So the electrons flow from the iron to the silver. Finally, in question F, in which directions do the cations and anions migrate through the solution? Nitrate anions move away from the silver cathode. So they're moving away from this because there's a certain negative charge is being absorbed in the form of silver cations depositing onto the silver electrode. So the nitrate anions move away into the salt bridge. And the chloride anions move towards the anode to balance the formation of charge, because iron atoms are coming off the anode, extra plus charges have to be balanced by the chloride. The NO3 moves to balance the deficit of Ag+, while the chloride moves out to balance the surplus of ferrous, or if you like, iron 2.